Hello, this is a presentation that I gave last month at the Atlantic Golf Superintendents Association Conference in Moncton, Canada, and it's a topic I'm quite excited about, the amount of clippings that come from a golf course putting green when it's mowed. In this presentation, I talked about four things. First, I gave a quick introduction and shared what this is all about. Then I answered a really common question that people ask when I mention that this is actually a thing and not a joke. They always want to know how much time it takes to do this. I'm then going to share some actual data that show what the data look like when this is collected and how they can be used. And then I'm going to close with something that I'm really excited about, which is what might these data be used for. I think they have the opportunity to revolutionize the way that turfgrass management is done. First, what this is about. You may have seen some pictures floating around on social media, or you may have heard that people are doing this. You may see people sharing pictures of a bucket or something, so you kind of get the idea, okay, somehow people are dumping clippings into a bucket and measuring them. Chris Tritibos shared this picture last year. They've used the hopper of an old Scott's rotary spreader, and it looks like they're using that as a funnel, somehow getting the clippings into a bucket, and then they're writing down those clipping numbers. And I've shared charts of this, so if you follow my blog or follow me on Twitter, you may have seen a number of charts where I show the distribution of the clipping volume, shows how it changes from day to day, and so on. And let me give you a little bit of an introduction to how I learned about this. And it's kind of an interesting story, I think. This is in Japan, and golf is a little bit different in Japan, but this is where I learned about the clipping volume. That's Mount Fuji in the background, and this golf course in Kanagawa Prefecture has two greens. You can see that the golfers out there are playing to the green that has the flag in it, and the green that doesn't have a flag in it is not being used on that day. This is also another set of golf courses in Kanagawa Prefecture. This is in Hakone. And the golf course on the far left there, if you look down there in the far left corner, you can see that there are two greens on some of those golf holes. So things in Japan on golf courses can be a little bit different. This is a golf course that held the Japan Open a couple years ago. This is Sayama Golf Club in Saitama Prefecture. The green on the left is the one that's being played to on this day. The green on the right is being rested, which means that you can do some maintenance on that green. That's the same golf hole. Now that green that's not being played on is being top dressed while the other green is still in play. I don't know if this is a common type of top dressing machine in whatever country you're in, but in Japan, this is a common way to spread sand with a Vicon type of machine. And there's all kinds of different maintenance machines in Japan. This is the Asahi, now it's a Hatsuta brand roller that is self-driving, or there's a hydraulic mechanism that can put those tires down and let you drive the roller from hole to hole. And also, this is very unique in Japan, I think, to load the mowers onto K-trucks and drive around with the mowers that way. And if you notice here, there is a bucket on the back of that K-truck. And what's done with that bucket is the clippings are measured. That's something that I learned about in Japan, and I used to think it was not really necessary, but now I've come to really find it quite fascinating. In Japan, it is common to measure a lot of data, and this is from a golf course in Okinawa, and the entire wall of the maintenance facility is showing these monthly maintenance records that show what work was done on what day. And I mean, it's excellent record keeping. It's showing the number of rounds, the temperature, the precipitation, all of these records. And it's typical in Japan to also measure how many grass clippings there are. Now, as I mentioned, this is something that I used to think was just collecting extra information that what would we really use it for, and I didn't think it was really necessary. I'm going to explain later in this presentation what it is that caused me to change my mind about that. When you make it part of the routine, you can just, when you go to mow a green, you have to remove the wheels from the mower, and you may bring along a blower, or in this case at this golf course, they're bringing a broom along to brush away any extra grass clippings that fall down on the green after the green is mown. And there's also a bucket there, and that bucket is used to measure how many clippings are collected when the green is mown. And there's different kinds of buckets that can be used. There's those transparent kind of buckets. There are also buckets that are graduated on the inside that one can measure. One can also mark, you can take a completely blank bucket, put water into it, and put gradations on it with a permanent marker so that you can measure how many clippings or what the volume of clippings are. Now, the way to do this is just to dump the clippings in, shake the bucket, let gravity, one doesn't compress the clippings, one lets gravity do the settling, and then one measures what the volume is. And this is a bucket in Japan. This is on a Facebook page of a golf course superintendent in Japan. And I saw that, and yeah, he's measuring what the clippings are from one putting green on that day. So it's relatively common to do this, but what can the data be used for? Well, if these data can be used to estimate the growth rate, then that could be kind of important, because the growth rate affects all of these things. It affects the playability, divot recovery, ball mark recovery. All of those things are kind of related to how much traffic the golf course gets. And it also, if grass grows too slow or too fast, it may be more susceptible to some diseases. And certainly it affects the green speed. It affects how much you have to mow. And it affects how much organic matter or thatch is produced, and consequently how much top dressing or cultivation may be required to deal with that thatch. Now, some people prefer to measure the weight of the clippings, and they say, rather than measuring the clipping volume, why don't you measure the clipping mass? And I used to kind of think the same way, because volume is sort of useless. We don't really care so much about the volume. What we're really trying to do is figure out what the mass of clippings are per area, because if we do that, there's some cool things that are nutrient related, and we get rid of the water content of the clippings. We can really start to do some very technical and precise fine tuning of the growth rate. But a golf course is not a research lab, and it's kind of nobody has a drying oven. It would be ridiculous, I think, to try to dry all of the clippings. So the problem is we also, in research, we try to separate the sand from the clippings. But when golf courses are top dressed and then you have the sand mixed in with the clippings, when you weigh it causes a big problem. I was at Keia Golf Club in Fukuoka I happened to be there on May 29th last year, and I saw them top dressing the green. And here's a chart that shows what the ratio is at that golf course from the fresh weight, the weight of the clippings, which they're actually measuring at my request. I don't recommend it to you, but they're helping me out with a bit of a research project, and they also measure the volume. They're doing that on 3 greens, the 1st, the 4th, and the 9th. That picture is from the first green. And they were getting a ratio, which is like the bulk density of the clippings, of about 0.3. It's bouncing around that 0.3 number in mid-May up until May 28th. And then on May 29th, they didn't mow, but they did the top dressing. And then they skipped mowing for a few days to let the sand settle in. And when they mowed again on June the 3rd, and then on June the 4th, and then on June the 5th, you notice that the ratio of the weight to the volume has spiked up to 0.4, 0.5. And it doesn't settle back down to 0.3 until about another week of mowing, or about 2 weeks after the top dressing. So what this means to me is that when you are measuring the weight of the clippings, you have more interference when you have sand contamination in the clippings. And that is going to be common on golf course putting greens, because they may have bunker splash sand, or they may have residue from top dressing sand. And so there's going to be variation in the weight that is not so real. The weight is going to have a bigger variation than just the volume, because sand, if you think of what this ratio of weight to volume is, sand itself is going to have a bulk density of about 1.5. And in fact, Andrew McDaniel, the superintendent at Kea Golf Club, at my request, he dumped some sand into the same bucket that they use for measuring the clippings, and then they weighed it on the same scale. And sure enough, when they just put straight sand into those buckets, they're getting a weight to volume ratio of 1.5. So we want to keep a consistent weight to volume ratio. Really what we want to do is just measure the volume and forget about weight, because when that ratio is spiking, it shows that the samples are contaminated by sand. And I've done some research with the Nichino Ryoka company. This is at their research area in Japan with different grasses. In the foreground, we have bent grass. In the middle, it's champion ultra-dwarf Bermuda grass. And then the lighter colored grass back here, this is Kori or Zoysia matrella. And there, that actually is a research center, so they do have a drying oven, and they very carefully had no sand in these clippings. So at this location, the volume and then the fresh weight and then the dry weight were measured. So based on that, we can develop a regression relationship or a predictive equation between the volume and the dry weight. And based on that, I'll just show the data for creeping bent grass. For creeping bent grass putting green clippings, based on those data, I'm expecting right now, for every 10 milliliters of volume of clippings, we can expect that those will weigh about 0.6 grams. And I expect also that there's going to be some additional research done on this over the next year and going forward. And we'll see if these preliminary results are accurate or if this number needs to be adjusted. So that's kind of an introduction of what it is, how it's done. What the objective is to estimate the growth rate somehow, why I think it's better to measure volume instead of weight, and also show that we can pretty accurately estimate the dry weight, which is what we're trying to do anyway, simply by measuring the volume. Now, this is a very short section. It's how much time does it take, because this is a question that everybody asks me, and it takes about 30 seconds when you're walk mowing to empty the basket into a bucket and measure the clippings. It takes 30 seconds or less. The buckets are going to get emptied anyway, or the basket of clippings are going to get emptied anyway. And I know people are always checking, golf course superintendents or turf grass managers, they're always checking how much the grass is growing. They're asking the operators how many clippings they're getting or how often they have to empty the baskets, or they're taking a handful of clippings and looking at them, looking at the quality of cut, looking at the size of the clippings, looking at how much material is being cut off of the grass plant. Turfgrass managers are looking at this all the time anyway, recording this information in their mind, certainly, if not on a piece of paper or in the computer. I think it's tremendously valuable to be more precise about this and to record it by a precise volume per area of putting green surface. And it takes about 30 seconds. And then, of course, you have to do the data input or data management. Let's say that's going to take 5 minutes per day. So it does increase the amount of work. I would suggest that the amount of extra work involved in doing this is minimal compared to the tremendous benefits that can accrue from making use of these data. So I'm now going to move on to the third section and show what these data are used for. And in this section, it's going to include the example that changed my mind about these data being just a waste of time to collect to be something that is almost essential now in the way that I think of turfgrass management. Chris Turtelbaugh wrote this on his blog last year in a blog called Optimize. He said that managing putting surfaces is at its essence about managing the growth rate of the turf. I'll let you read the rest of that yourself. This sounds to me like exactly what we're trying to do, right? We're trying to make the grass grow just the right amount. If it grows too little, we have problems. If it grows too fast, we have problems. But if we don't put a number to how much it's growing, how can we know if it's just right or if it's too much or too little? We always talk in turfgrass management. With some things, everybody knows the numbers. I can communicate or ask questions. What's your mowing height? Everybody knows the answer to that. How much water are you putting down? Everybody can answer that. What's your spray volume? Everybody can answer that. How much nitrogen have you applied so far this year? Almost everybody can answer that. How often do you top dress? Everybody can answer that. They can put numbers to it. But the objective of what or what's your green speed? Everybody knows that too. But the thing that we're really trying to do to produce that green speed or to produce the quality surfaces that we're trying to produce, what we're really trying to do is adjust the growth rate to get there. And we talk with precision about a lot of the things that we do that are related to the growth rate, but we don't have a language or a unit to actually talk about the growth rate itself. And I think the clipping volume has the opportunity to be that. So with the growth rate or the volume, what we can measure, what we can do with these data is we can measure how much the growth is, and we can also measure its variability. We can check that from day to day, green to green, machine to machine, and year to year. I think all of these are valuable, and it would make sense to me that we would want to minimize the variability. So if we know that some greens are growing more than others, then we might either want to reduce the growth rate of the greens that are growing faster, or we might want to increase the growth rate of the greens that are growing slower. There's a number of things that one can do to improve the consistency of the turf, or perhaps identify microenvironments where the grass is not growing well. All of this can be done if we actually measure the growth. This is what the data look like. This is from Keio Golf Club in Fukuoka, Japan. This is zoysia grass. And this is the data from last year, from 2017. Each one of these dots, each black dot here represents a single green on a single day. You can see that there's quite a lot of variability, and you can see that it starts off relatively low in the spring and it peaks in the summer, and then it goes down in the autumn. This is Manila grass or Kori grass on the greens. This is a warm season grass. So in that climate, the grass goes dormant in the winter. So one can expect that the peak growth will be in the summertime. I can look at the average for each day. So now the green dot shows the average amount of clippings for each day. And you can see that this is kind of tracking along pretty good, except it bumps up sometimes. When it bumps up, do you notice that there's a gap immediately prior to that? This was the May 29th top dressing and then skipping a few days. So if you skip a few days, it's normal that the leaves will be more and you'll get more clippings after that, and then it drops back down to be normal. And this was another skipped mowing. This was another top dressing, and then the volume spikes up and then it drops back down again. So anytime that the mowing is skipped, it's normal for you to get more clippings the next time. And one can also look at a moving average. I think this is especially useful. This blue line now shows the 7-day moving average of the clipping volume through the year. And it's peaking at this golf course at about 4.5. The moving average is about 4.5 liters per 100 square meters per day in midsummer, and it's dropping down to close to zero. It's sometimes in the autumn, certainly close to zero when mowing was initiated in March, because the grass is dormant and not really growing much from about December until March. So this is something where you can say, for our golf course, here's how much it's growing. And these are the monthly and annual totals for the past 5 years. 2013, the clipping data was started recording in mid-July of 2013. And so this is the red numbers. These are the monthly totals. And you might notice that in 2013, in the autumn, it's a bit higher, it's a bit more. And then in 2014, that's the blue, it's a little bit less. 2015, also a little bit less. And then in both 2016 and in 2017, it's slightly more coming through the autumn. So one can compare year to year. One can compare month to month. This very much looks like the growth curve for zoysia grass in that climate, where it doesn't really grow in the winter and it grows in the summer. You can also see the monthly totals for this grass. They're ranging from about, in midsummer, it's ranging from about 40 to about 120 liters per 100 square meters. And now for the story about why I come to think these data are really useful. This is zoysia grass, or cori, and cori is notorious in the summer for being a slow putting surface, but it's brilliant when it's dormant. It's brilliant when it's not growing. So in Japan, golf is a year-round sport, and in the wintertime, these putting surfaces are really fast, really smooth, and great. But this golf course holds a professional tournament on the Japan Men's Tour at the end of August every year, and this tournament is called the KBC Augusta Tournament. The superintendent, Andrew McDaniel, started working at Kea Golf Club, the host of this tournament, in 2013. I've had the chance to measure data about the green speed every year during the tournament since 2013. And for this particular grass, for cori, I've measured it in Japan, so that it's the same type of cori at a lot of golf courses during the summer. And the average green speed of this grass during the summer is 7.2 feet. So that kind of shows you what type of speed you can expect to have with standard maintenance on this grass during the summer months. Now, at the professional tournament, Andrew wants to have the greens as fast as possible. And that first year in 2013, this shows the morning Stimpmeter speed after a double cut and roll, and the green speed during the tournament was just getting up to just over 9 feet. Now the greens, this picture is from 2013. The greens are beautiful. The ball was rolling very true, but the speed just wasn't quite as fast as Andrew wanted. And we did notice something though, and this isn't something that we were really looking at during the tournament, but it's a Japanese golf course, and it was common to measure the clipping volume. So they had the clipping volume data, and we looked at that and we saw, wow, during the tournament, as the green speeds were getting better, and the green speeds were the best on the final day, and that was also corresponding with the lowest clipping volume. The clipping volume was going down. So as Andrew was planning for the 2014 tournament, he said, let's see if we can adjust the maintenance practices to have a clipping volume that starts off the week at about 1 liter per 100 square meter, or can we, somehow go through the week at about 1 liter per 100 square meters, so that may allow us to have better green speed. And here's the 2014 data. Coming into the week, it was a little bit above 1 liter per 100 square meters, but then for each of the tournament days, for the Thursday, Friday, Saturday, Sunday, the morning clipping volume was less than 1 liter per 100 square meters. And here's the green speed for 2014. Now the green speed, as that clipping volume was going down, the green speed was going up from 9.5 feet to 10 feet. Remember, this is on a grass where the average speed during summer is 7.2 feet. So this was something that the professionals were really raving about. They said they'd never seen cori greens like this, and it was really amazing and great. For the next year, Andrew wondered if he could get the clipping volume even less. Now, there was a typhoon on August 25th in 2015, so the greens weren't mowed. And then the next day, of course, naturally it spikes up a little bit. And but there was the general trend of decreasing clipping volume. And in 2015, again, it was less than 1 liter per 100 square meters. And the green speed now was above 10 feet for every day of the tournament and getting up to actually over 11 feet for the final round. And in 2016, the clipping volume was very similar. Coming in again, he was able to get the clipping volume at less than 1 liter per 100 square meters. That's with a double cut. So each single cut would be giving about 0.35 or 0.4 liters per 100 square meters. And in 2016, boom, there's the speed right up around the high 10s to almost 11 feet during the tournament rounds. And in 2017, clippings again coming in very good during the tournament or leading in to before the tournament rounds to just under 1 liter per 100 square meters. It was really, really hot this year, and the grass was just growing incredibly well. So it bumped up above 1 liter for the Friday and Saturday. And the green speed again, right up there, pushing 11 feet. So Andrew and I have talked about this a lot, and now looking at clipping volume going into the tournament is one of the main things that Andrew's looking at. Based on the clipping volume, Andrew can predict the green speed, and prior to the tournament, he can adjust growth regulator, he can adjust mowing, he can adjust fertilizer to try to get the the growth rate just the way he wants. And he knows that if he can get the growth rate just the way he wants, he will achieve the playing conditions that he's looking for. Now, that was the story of what convinced me. That was a specific case, and I'm sure there's other specific cases that will be specific to individual properties where one can solve problems that otherwise couldn't be solved with such precision by looking at how much the grass is actually growing. Now, here's something that's a little bit speculative, but it's something that I'm really excited about what I think these data might be used for. I think that one will be able to fine-tune the nutrient supply based on harvest, because if one knows how much is coming off the greens, one can know how much needs to be resupplied to completely or exactly match what is being removed. One can be more precise about when to mow again. That's going to reduce the carbon emissions from the golf course if one avoids any unnecessary mowing. One can also improve the health of the grass conceivably if one is optimizing mowing. One can really test and check the effect of growth regulators. I like using growing degree days to predict the duration of growth regulator effect. I think it's also useful to actually measure what that is on one's own property, and one can do that precisely with the clipping volume. And also, the top dressing requirement, it would make sense to me that as the grass is growing, the amount of top dressing to apply should be proportional to the amount that the grass grows. So one should be able to really fine tune the top dressing requirement, doing things like nutrient supply, growth regulators, mowing, and top dressing, doing all of this based on a grass-centered schedule rather than on a calendar-centered schedule. This should be a way to optimize the performance. Now, I want to share something about what tends to happen when people start measuring these data. This is from a creeping bentgrass golf course near Tokyo, and the superintendent has shared the data with me, and from 2013 up to 2016. And this golf course superintendent took over in 2013. That's when he started working there. So the first year that he was there, this was the monthly totals and then the annual amount you can get by summing the monthly totals. And I want you to notice something. In 2013, he got this type of growth. In the next year, in 2014, he got slightly less growth. And then in 2015, it's even less. And in 2016, it's even less. So you get here an annual curve of growth, but you also see there's this progression. 2013, 14, 15, 16, he's getting a little bit less growth every year. And this is a top course. This is a course that holds professional tournaments. It's a course that I've visited on a few occasions, and I've noticed that the conditions are just getting better. So in this case, as the superintendent took over, at first he didn't know, or he was letting the grass grow at a certain rate, but as he came to know the property and realize how much growth was required, he was able to reduce the growth. Now, it's not reducing growth just for the purposes of reducing growth. This is a high maintenance golf course that hosts professional tournaments. He's trying to optimize the playing conditions. And as he's optimizing the playing conditions and measuring the clipping volume is going down. These are those data summarized with the annual totals, and the volume goes down from 444 liters per 100 square meters to 237. Using that relationship that I showed earlier, we can estimate the dry weight of those clippings, which is from 266 grams per square meter, dropped all the way down to 142. And I know the nitrogen that was applied. The nitrogen applied was from 2.6 down to 1.7 pounds per 1,000 square feet. In metric, that would be about 13 grams per square meter in 2014, or 130 kilograms per hectare, down to 1.7 pounds, which would be about 8 grams of nitrogen per square meter, or 80 kilograms per hectare. Now, when you get less growth and when you're adding less nitrogen, do you think the grass is going to require more top dressing or less? I'm sure that it's going to require less. Are you producing more or less organic matter, more or less thatch? It must be that you're producing less as the grass grows more. So that means one can conceivably do less top dressing, less core aerification, less verticutting, do less of all of these things that are disruptive to play, and have more days during the year when the greens are in optimum condition. I think it's really useful to use these data as a moving average so that one knows for special events such as the KBC Augusta tournament. We're going back to Kea Golf Club now, looking at a double cut before one of the tournament rounds. One knows how to produce these conditions year after year, and one can be 6 weeks before, 2 months before, and already start adjusting it to make sure that one hits the targets that one's trying to hit. And this is good for a member guest, or for a club championship, or just for everyday play. One can have different targets and then try to hit them. This is looking again at Kea Golf Club data. This is the 7-day moving average, which is useful. We can see in 2013, so these are for the month of August. 2013, it was just growing a lot. We didn't realize that it was growing too much. We thought because the grass looked great, but by actually measuring it and then realizing that the green speed was going down in the same way that the clipping volume was going down, the next year, 2014, Andrew adjusted the maintenance practices and got less growth, and the green speed was even better. And then in 2015, 16, and 17, for the tournament that's held at the end of August, Andrew's been able to get the 7-day moving average to be down right around 1 or just less than 1 liter per 100 square meters. And in doing that, he's gotten green speeds from 10 to 11 feet, which for core eye greens is superb at the peak growing season. Now, this is something that's unrelated to green speed, but it's another piece of data that I collect, and this is the firmness of the greens. Now, this is with the Clegg hammer. This is measuring the deceleration. It measures when you drop a 500 gram hammer onto the green surface. It measures the deceleration in gravities multiplied by 10, and the bigger the number is, the firmer the surface is, the more rapid the deceleration is of that 500 grams that's dropped onto the surface. 2013, 2014, these greens are firmer than average. The average is about 87. All the greens I've ever measured, the average is 87. So these are firmer than average, but nothing spectacular. And 2014, 2015, 16 is in the purple. You see there's this progression. It's kind of getting firmer every year. 2017, the greens were the firmest of all. Really, really excellent surfaces. One doesn't really find a ball mark on them. One really had to be in the fairway to hold the playing surface, to hold the ball on the green. Just excellent. And these surfaces were produced with 2 top dressing events in 2017. 2 top dressing events, 0 corings, 0 solid tine aerifications. So Andrew and I are closely monitoring the organic matter accumulation on the greens. We're closely monitoring what the conditions are. But what Andrew has found is he can produce firmer greens and faster greens with less clipping volume and only 2 top dressing events per year. That won't be for everyone, but I think it's pretty awesome that one can get less clippings, and based on having less growth, one can have improved conditions and one can minimize the amount of top dressing, minimize the amount of coring that's required. So some places may need to increase the growth rate to get the desired conditions. For example, you may go measure some of your surfaces and find that the best surfaces are the ones that are growing the fastest. So then you find out what that number is, and then you try to hit that. I'm not saying that everywhere needs to grow less, but there must be an optimum amount of growth for any particular property based on the amount of traffic, based on the season. And once one knows that number, one can then adjust the maintenance practices and try to find it. I write about this and other exciting turfgrass topics on my website, www.asianturfgrass.com. And also, I often share information about turfgrass on my Twitter account @AsianTurfgrass. I hope you find this interesting, and I am sure to be talking about this topic quite a bit more in the upcoming years because it is an area of active research, and I am really excited about the opportunity that we as an industry have to more systematically improve and optimize turfgrass conditions through the measurement of clipping volume, which is done not to get a volume itself, but to try to estimate the dry matter yield or the actual growth rate of the grass. Thank you very much for your time, and I will hopefully have a chance to talk with you in person at some upcoming seminar. Thank you.